Hi, my name is Sophie, and I'm a student at UCSF, University of California, San Francisco, and today I'm going to talk to you about the Doppler effect. I'm going to talk to you about the Doppler effect in 4 parts. First, I'm going to give you a little background on sound. Then, I'm going to define the Doppler effect. Third, I'm going to give you some examples of the effect. And finally, I'm going to go over how the Doppler effect works, both conceptually and physically. I'm going to cover these first 3 topics in this first video, and then I'll go over how it works conceptually and physically in my next video. So let's begin with a background on sound. Let me clear the screen here, and we'll go over what sound is and how it works. So sound, by definition, is a mechanical wave that's transmitted by the vibration of molecules. And when we think about sound, we generally think about sound in 3 parts. First, there's the generation of sound. Then there's the transmission of sound. And finally, there's the perception of sound. So, let me switch over to a pen here. If I were going to give you an example of the generation of sound, I could use a dinner bell. And this dinner bell, when I shake it back and forth, can be used to generate a mechanical wave. And this wave can vibrate molecules in the air. After the wave has been generated, it can be transmitted through space by propagating this vibration of molecules through the air. And then the final stage in sound movement and transmission is actually the perception of sound. So I'm going to have a man here who has some very big ears. And he is able to detect this vibration of molecules traveling through the air and perceive it. So in this example, my dinner bell is the source of my sound, and my man here is my observer. So now that we've done a little background on sound, I'm going to go ahead and go over what the Doppler effect is. And to do that, I'm going to advance to the next slide. And I'm going to get rid of our definition up here of sound. And I'm going to go ahead and describe the Doppler effect. What the Doppler effect does is it explains the changes in the perceived frequency of a wave when the observer is moving relative to the source. So, if we go back to our example of the man with the dinner bell, our dinner bell is the source, and our man is the observer. And the Doppler effect explains how the frequency of this mechanical wave that's being transmitted through the air changes when the man runs towards the dinner bell. So the difference in the sound that the observer, our man with the big ears, is hearing when he's moving relative to when he's standing still is explained by the Doppler effect. The most common way we see the Doppler effect is not actually using a man running towards a dinner bell. We most often see it described when we see people talking about ambulances and trains. So, I live near the train station, and I take the train to work in the morning. And when I'm getting ready for work, I can hear the train as it comes down the track, approaching my house. It blows its whistle. If I'm late, I can hear the train pass my house and blow its whistle once it's past me. My ability, as the observer, to tell the difference between when the train is here and when the train is here is due to the Doppler effect. So, now that we've covered a small background on sound, a definition of what the Doppler effect is, and some examples of the effect, we're ready to go into how it works. So I'm going to stop here, and I'll go over how it works both physically and conceptually in my next video. Thank you so much.